Well, one thing I just wanted to know how many of you are like know how recursion works? Clear idea of recursion, how it works? Hmm? Or should I discuss some basics? Because today I want to focus on some problems based on the recursion. Do you need some revision kind of thing before I proceed with the problems? Or your
One can give some revisions.
Yes,
okay,
sir. A bit of revision.
fine. So any problem when we consider like we can solve that problem by using recursion or by using iterative problem solving technique. What is this recursion and iterative is? Let's say we need to perform set of operations for n number of times. Means we have to do same thing again and again until a condition is not met. So in that case, either we can go for iterative like by using for while do while, or we can use by using recursive methods. So all the problems which are can be solved using iterative techniques, we can also solve them by using recursive methods. Well, uh, like there should be a termination condition in loops, otherwise it get into infinite loop. Similarly, in recursion also there should be a termination condition, um, like that is called base case. There should be end condition to get rid of that particular method. So base case and the other one in which we call a method again and again is known as recursive case. Now, basically recursion uses stack. In other words, stack is one of the important applications of recursive methods. In compilers, whenever user calls the method itself, compiler it uses a stack to keep track of current method call. Okay. Now, for example, we are calling, we are defining a method first called M1, which takes one parameter of type integer. If n is less than 10, display n value. Else, this is base case. This is recursive case where we are calling the method itself m mod 10. Okay, very simple one. If n is less than, if n is a single digit number, display it directly. Otherwise, recursively call method m1 with n by 10 and display n modulo 10. Sorry, this is n modulo 10. Now coming to main method. Let's say we are calling, since it is a static method, we can directly call m1 of 123. Okay, m1 of 123. Well, end of the main and end of the class also. Now, can any one of you answer what would be the output of this program when we call m1 with value 123?
1, 2, 3. Separated 1, 2.
1,
Next line
1, 2,
2.
3 or 3, 2, 1.
3 to 1, sir.
3 to 1. How many of you are agree that the output is 3 to 1, not 1 to 3? Hello? Does anyone is there anyone who is expecting that output is 3 to 1, not 1 to 3? What about 1 to 3? Only one student said 1 to 3 and other one has said 3 to 1. Now I'm asking
1, 2, 3, sir.
1,
Hello,
2,
sir.
3. Yeah,
1, 2, 3.
1, 2, 3. Is anyone there who agrees that the output is 3 to 1?
Sir, what's the input? 123, right?
Yeah. Hmm?
Yes, sir. 1, 2, 3.
1, 2, 3. Okay.
Sir, 3 to 1.
Let's okay, fine. So the output either 1 to 3 or 3 to 1, that we need to discuss. I will take this example. Now from main method, we are calling m1 of 1, 2, 3. So the execution control is transferred to definition of this method. It goes to the execution control goes to the beginning of this method m1. Now this n is receiving value 123. Now is that value less than 10? Hmm? Is
No, sir.
120? No. So it goes to else part. So whenever else part, it goes to else part, all the statements inside else part should be executed. So what is the first statement in else part? M of means sorry, M1 of, we are calling the method itself 123 by 10. 123 by 10, what is the value? 123 by 10?
1, 2.
1, 2.
1, 1, 2. So we are calling
M1.
M1 of 12 and system dot out dot print. Let's say it is not a println, just a print statement. 123 mod 10. 3. Okay. It should execute statements in a sequential manner. So again, the first step is calling M1. Now M1 is called with value 12. Is 12 less than 10?
No.
Is 12 less than 10? No.
M1 of
Then
1.
again it goes to else M1 of 12 by 10 now. 12 by 10 is 1 and system dot out dot print 12 mod 10. 12 mod 10 is 2. So in else part we have two statements to execute. Again first statement is M1 of 10. Sorry, M1 of 1. Now when we are calling with value 1, what about this if condition? If 1 is less than 10. Is this condition true?
Yes, sir.
If
1 will
if
do.
this condition is true, display n. Now what is the first output that we are getting onto the screen? Display 1. Now are there any statements to execute inside if condition?
It just comes out of the methods.
It is just end of the step.
Returns.
So it returns to where? It doesn't return to main, but it returns from
Calling function.
where this method is called. So it is called here. So this M1 of 1 execution has completed. Now it follow with this sequence system.out.print 2. Now display 2. After this there are no steps to execute inside else part. In fact, this is the end of the method. Then it should goes back to the method from where this current version of method is invoked. So it goes back here. Then we are done with executing M of 12. Then we display 3. Then after this, again it goes back to main. If there are any other statements inside main after the M1 of 123, those things will be gets executed. So the output is 123. So are you finding any sort of stack here?
Yes, sir. M1.
First
But
step is actually what is visible to us is display 3. On top of it we have display 2. On top of it we have display 1. It is executing in reverse, right? First 1, then followed by 2 and then 3. So for recursion, it uses any compiler, not only Java, in any programming language, the recursion concept is remains same and it uses a stack. Okay, now it's about recursion. Now the questions are see programs which we have done so far can be implemented using recursion and vice versa is also possible. Now in today's class, I am thinking of discussing few problems which are very well-known recursive problems to solve them using iterative. Because one way or other way, converting iterative problem into a recursion, if you understand the conditions well, you can easily code it. But vice versa is not that easy. Let's say we are taking some recursive problem which is easier to implement by using recursion, but we want to convert into a iterative, then we need to make lot of efforts as there is involvement of stack here that we need to take care. Okay, so we can also think of it's a problem from stack. Whenever a standard recursive problem is asked to solve by using iterations, we can also consider it as a problem from a stack. Stack everyone knows there will be array of elements. The last element is known as the topmost element, and always insert the element at the end of the array, and when we remove the element, that should be at end of the array. Means both the operations of push and pop should be done from the one end. That end is called top. Well, it's not any thing that you need more knowledge on, stack and all. It's a very basic linear data structure with the two operations, push and pop. Okay. Now we have discussed one standard problem like is quick sort. How many of you remember quick sort, or should I thoroughly walk through this sorting technique also? Just idea. Do you guys need some sort of revision? Quick sort, how it works? No responses. Hello. See, you don't need to look at someone else. We all are attending from remote locations. Even I don't see your face as I have shared my screen. I don't know even who is talking and all. It's whatever you feel, please answer that. I'm not asking any technical question. Do you need revision on quicksort?
Let's go through it, sir.
So quicksort is a divide and conquer method. Like we'll be having elements and let's say this is first location is P, last location is R. Okay, first location is P and last location is R. This is input A of P to R. First index is P, last index is R. Now our objective is to apply quicksort technique on this array such that all the elements are arranged in increasing order. That is, if you consider any A of I should be less than A of I plus 1. A of I plus 1 for all I greater than or equal to 0 and I less than n. Okay, how we apply quicksort is, it is also called divide and conquer. Solve the like we have n number of elements. We divide that into a two subproblems, not necessarily with the equal size. We divide into two sublists such that one sublist contains elements from P to Q minus 1 and another list contains elements from Q plus 1 to R, such that all the elements in A of P comma Q minus 1 are less than or equal to elements in A of Q plus 1 to R. So we are dividing this list into two sublists, and one sublist index range is from P to Q minus 1 and another sublist range is from Q plus 1 to R. And we should divide in such a way that all the elements in first sublist should be less than or equal to elements in second sublist. By looking at the indices or the range of indices that is represented here, like A of P comma Q minus 1 and Q plus 1 to R, are you finding any missing index in that range?
Q
Hello, are you
missing, sir.
fine?
Q missing,
Yeah,
sir.
Q is missing. Means in one sublist we have P to Q minus 1 in N. So what is that Q? That Q is we need to partition that given list into two sublists. To satisfy this condition, we need to follow an approach. That approach is called partitioning algorithm. That is the bottleneck of this technique. That is the bottleneck of this quick sort. We need to partition. So that technique is called partition. What we do in that partitioning algorithm is that we pick up, it is just the convention, it's not the mandatory, it's the convention that we consider first element as pivot element. Pick first element as pivot element, and based on that element perform the partition. Straight away I am taking an example as it's not a regular DS class. I want to finish this in 10 minutes. So the algorithm is like, let us consider elements some randomly 10, 20, 90, 70, 5, 1, 2, 3, 4, 9, then let's say 25. So in partitioning algorithm, we consider first element as pivot. And the index next to pivot element will be considered as F. And the index which is last in that list is considered as L. Now our idea is we should move F in towards right side, L towards left side based on some condition. The condition is that we should move this F towards right side until we find an element which is greater than 10, which is greater than pivot. And similarly, we should move this L towards left side until we find an element which is less than pivot. So from right side, we are identifying less than pivot. From the left side, we are finding greater element. If we identify if the current A of F is greater than pivot, we stop incrementing F. And if the current A of L element is less than pivot element, which is 10, then we stop decrementing L. Now tell me, is A of F greater than pivot in this example? Huh?
Yes,
Is
sir.
it? Yes.
Yes, sir.
Then we need not to increment this. We need not to move it towards right side. Now is the element at last location A of L less than pivot? 25, is it less than 10?
No, sir.
No. Then we should move it towards left side. Moving towards means L minus minus. L minus minus. Okay. L minus minus. Now, when we decrement L value, what is A of L now? Next A
9.
of L is 9.
9.
So is 9 less than 10? Yes. Now at this moment L is at last but one location, F is next to pivot element. Now we need to verify whether F and L are crossed each other. I mean to say if they have crossed each other, let's say it is moving towards right side and it is moving towards left side. If they crossed each other, we need to swap pivot element with A of L. If they have not crossed each other, technically or logically, if F is less than L, which means they have not crossed each other. In that case, swap A of F and A of L. So we need to swap these two elements. So now 10, 9, 90, 70, 5, 20, 25. Still we have L at this location, F at this location. Now again we should continue this. Is the element at F location is greater than pivot? Is 9 greater than pivot after swapping? Hello?
No, sir.
No. Then we should increment. We should move F. Now after incrementing F, 90 is greater than 10. Now is the element at L is less than 10? No. Then move this towards left side. So now we are checking is 5 less than 10. So the first condition, this is true and this is true. After moving F towards one position right side and L left side, then we check is when F is at this location and L is at this location, are they crossed each other, F and L? Hmm? Whether they
No, sir.
crossed each other? No.
No, sir.
Then if they have not crossed, we have to swap A of F and A of L. So now 10, 9, 5, 70, 90, 20, 25. Now this is F and this is L. Now if we continue further, still our pivot element is 10. That is not updated. Now A of F is not greater than 10. So we should move it towards right side. Now it is 70. Now when it comes to 90, we should identify an element from the right side which is less than 10. When we go in this direction, only when L comes to this location and F goes to this location. Finally, this when F is at this location, A of F is greater than pivot. And when L is coming towards this, when L is at this element 5, which is less than pivot element. At that moment, if you see whether they have crossed each other or not, A of F and A of L, here it is, and L is at this location. Crossed means if L is less than F. If F is less than L, not crossed. If L is less than F, crossed. So this is location 0, 1, 2, 3, 4, 5, 6. Now this location is 2 and F location is 3. So they have crossed. If they have crossed, then swap pivot and A of L. When we swap these two, 5, 9, 10, 70, 90, 20, 25. So our partitioning algorithm is considering first element as pivot. Now tell me, is that 10 is the third smallest element in this list? Hmm?
Yes, sir.
What? So is that positioned at third location?
Yes, sir.
So now this list, all the elements left side to that first pivot are in list P comma Q minus 1. This is Q location, which is already placed in right place. Now this right list is from Q plus 1 to R. This index is R. That's why in this definition, Q is missing. Means partitioning algorithm is basically about pick up one of the elements as pivot. Conventionally, we are taking first element as pivot and we are following some approach. By using that approach, we are placing pivot element in its right position such that all the elements, if you look at elements in the left sublist are less than elements in the right sublist, right? 5 and 9 are less than all the elements in
Less.
right sub. Yes. So now this is the approach. Now what we do using recursive technique is, let's say we are calling void quicksort. What we need to consider is, let's say, list, and what is the first index and what is the end index. P comma, sorry, R we are considering, right? P comma R. Why we are considering P and R? Is it not that easy to look at the arrays first and last indices, as first index is 0 always and last index is a dot length minus 1. But when we are, again we need to recursively follow this, sorry, again we need to recursively follow this solution for left sublist and right sublist. When we are recursively following for right sublist, this becomes P and this becomes R, and this is P and this is R for the sublist, left sublist as well as right sublist respectively. So the first and last indices are changing based on the whether we are calling it recursively for the left sublist or for the right sublist. So one of the this algorithm is partitioning technique. Let's see, we are calling it partitioning of A comma P comma R. A is the array, P is the first index, and R is the last index of that particular list. Then it is expecting to return the value. That value will be stored in Q. Then after this, we should call recursively quicksort for left sublist. For left sublist, the range is P comma Q minus 1. Right? Q is already placed in its right position. So P comma Q minus 1, and we should call this quicksort recursively for right sublist. Q plus 1 comma R. So for right sublist, the first index is Q plus 1. There is no change in last index. For the left sublist, no change in first index, but last index is Q minus 1. And we should perform this recursively only if at least there are two items in the list. Means P should be always less than R. The first index should be always less than R. And only we can see, to partition a list into two sublists, at least we need two elements. If there are two elements, then only P is not equal to R. What happens if P equal to R means there is only, if first index of the array is equal to the last index of array, which means that there is only one element in that array in which we cannot perform partitioning. How can we divide an array with one element into two sublists? It's not possible, right? So the termination condition here is P less than R. Okay, this is recursion. Now our idea is how to solve this problem by using iterative technique. Before that, as I said, the main logic is about partitioning, and it is expected to return some integer value and keeping all the methods as static, as we are not interested to create any instances. This method, partitioning method, is expected to return integer value. What we are considering is A int P int R. Now our first job is we need to consider first element as pivot. First element index is always P. Pivot is equal to A of P. Then next step is consider the index of next element of pivot as F, which is always P plus 1. And third step is consider last index in that partition as L. L is equal to R. Now what we are going to do is we need to move F plus plus. We need to move F. When we need to move F based on our previous condition, can any one of you answer this? When we need to increment the F or when we need to move F towards right side. Hello. Hello.
Yes, sir, we can hear you.
Yeah, that's okay. I'm asking a question. When we need to increment F, when we need to move this F towards right side. That's the question. Hmm? This
If
much
A of
example I
X is,
have.
if A of F is greater than pivot, sir.
If A of F is greater than pivot, we need not to move it towards right side. If it is less than, we need to move it, right? Am I
Yes,
correct?
yes, sir, yes.
See, don't get confused with these conditions. Conditions always what we are, putting in a simple terms, simple English. It's completely while when it comes to the condition, it's quite opposite. So, thing is, if A of F is less than pivot, then we should move this element towards right side. So that's why I'm keeping L. And similarly, if A of L is greater than pivot, then we should move L towards left side. That's fine. So we are moving F based on this condition, moving L based on this condition. If they have not crossed, means if F is less than L. See how I have explained this procedure step by step. The same thing I am putting in program. So we are moving F if A of F is less than pivot. We are moving L towards left side if A of L is greater than pivot. After that, after we are identifying an element from the left side which is greater than pivot and the element which is less than pivot from the right side. After that, we are halting, moving F towards right side and L towards left side. Then we are checking whether F and L crossed each other or not. So logically crossed each other means F should be, if F is less than L, not crossed. If they have not crossed, are we exchanging A of F and L or we are exchanging pivot with the A of L? Which one we are doing? How we have done here? Hmm? Hello.
Sir, if F less than L, we are swapping A of F and A of L.
So T equal to A of F. A of F is equal to A of L and A of L is equal to T. Okay. And after this, are we stopping with only one step? No. Our main motto is we will continue this until they cross each other. So again, these steps of considering A of F and then A of L and again incrementing f and decrementing l, that should be continued, right? So what we do else, if f is not less than l, what we are going to do is we swap. Already pivot is there as a temporary variable now. So what we can do here is a of p, a of p equal to a of l, and a of l is equal to pivot. Okay, only swapping. First step is not required as we have that element, first element in the pivot location. Okay. Now after this, what we need to do is, now what is our location q? Is it the location L is q? Hmm? After swapping a of L, L is at location 5, no? Then we found that here F and L crossed each other. Then we have swapped 5 and 10. That is the location, that is the right location for the 10, which is maintained by a variable called, the reference variable here is, reference index is L. So that is the one, that value should be written to where, from where this partition method is called, to that method we need to return this L. So we return L. Return L. So these two steps of moving F towards right side and L, that has to be performed until we execute this step. So what we do, we keep this in another while loop, which is a dummy while loop, means it initial condition is always true. Since we have a written statement, where does it returns? It returns the execution control to the method in which we have invoked this partition. So L will be written here, that is the queue. Then we recursively call this method quicksort for left sublist as well as for right sublist, provided there are at least minimum 2 elements in that partition. Okay. So this partitioning technique we are not going to update anymore. It is remains same. What we want to work is, this is the standard quicksort algorithm. This is standard quicksort algorithm. Now whatever method is defined here, this we want to make it iterative. How to make it iterative? So we want to change this recursive approach to an iterative approach. How to do? Hello. So instead of recursion, we need to use a stack. Okay, we need to use a stack. Now question is how to use stack in this case. So what is the initial range of array when we are calling it for first time? Initial range means initial range of what is the first index and last index?
P and R.
P and R. Okay, P and R. Or we can also say 0 and length minus 1. 0 and length minus 1. After this, we are getting, based on our partitioning algorithm, we are getting Q. So after that Q, we do we are getting two more lists, which is P2 Q minus 1 and Q plus 1 to R, right? So we need to focus on how this range is generated. And when we are calling recursion, which sublist will be recursively sorted first in this, based on this? Based on our previous discussion, like we have taken print one left followed by right. Again, that left might divide into two partitions, again in that left, then again left. Once that extreme left is completed, it goes back to one step previous one, and it performs the quick sort recursively for the see what idea is. Initially we have a list, it is dividing some x numbers into left sublist and y number of elements into, again it will be x1 y1, sorry, x1 x2 y1 y2. Again, let's say this is x3 x4 x5 x6 y1 y3 y4 y5 y6. Now, if x3 has only one item, it's done. If x4 has one item, done. Then it goes back. So after completing this extreme left, it goes to right. After this, again it comes to this left, completes. Then this right. Then it goes to the original right sublist, and so on. This is how recursion is working. To understand this, I have explained the simple example of print 1, 2, 3. Okay, so now based on this generation sequence, we have to define the method. So I'm making it a new method. So instead of that recursive approach, call iterative quick sort. Now we don't need any indices, because in recursion we need what is the first index and last index, but here it is not required. Now let's say we have a stack S1. As I discussed earlier, for every recursion, there should be a stack to implement that. Okay. Now we have a new stack. One stack is created. Now question is, what is the first array range? First array range is q to n minus 1. Q to n minus 1. So that range should be pushed onto the stack. That range should be pushed onto the stack 0, comma n minus 1. Because as when we are calling it initially, p is equal to 0 and r is equal to length minus 1. That is the initial range of the list. So initially on stack will be copying these two. What is required here is only what is the range of left sublist and right sublist. Anyway, partitioning remains same. Partitioning we have not done using any recursion. It's an iterative problem technique. Just a minute. Hello, sir. Sir, 3 to 5 class. Yeah. Yeah, that we can discuss it. Even I too got it. So we'll discuss after my class. So are you in campus? Okay, then I will call you around 6:30 because you might be on the way back to your home. No? Yeah, fine, fine. Yeah, fine. So partitioning is only iterative technique. Only recursion is this one. So we need to keep track of what is this P or for left sublist and right sublist. If we can take care enough about that, our job is done. So initially the range is P comma length minus 1. Now what we do, we push that element, we push first element, first index into S1. And similarly, we push A dot length minus 1. Okay, A dot length minus 1. So our first array range is 0 to n minus 1. That's what we are pushing now. On top of the stack, we have 0 and n minus 1, length minus 1. Okay. Now, we need to continue this while stack is not empty. If stack is empty or okay, these constants we can use, these methods we can use. These
Sir,
are
are you using two stacks?
sorry S1 now. S1 dot push. Yeah, only one stack. So always our idea is on stack we push what is the first index and the last index for that partition. So first initially 0 and n minus 1. Now what we do, we check is S1 is empty or not. Okay, it is empty or not. If it is not empty, means we should keep not empty. Sorry, it is a case sensitive. No, in Java, if you see any method, first character is lowercase. After that, each word is of capital one. So it is capital E. If it is not empty, then what we do? First, we need to consider that entire list, and we have to create as two sublists. For that, what we do, int p equal to, if we pop, are we getting first index or last index? When we pop, when we apply pop on S1, which one we
Last
get?
index.
Last index. So as per our recursive approach, our last index is represented by R. R equal to S1 dot pop and P equal to S1 dot pop. Now we are getting two elements. Okay, now we are getting two elements. Now tell me R and P, when we need to, when we are calling this quicksort recursively, when we are calling only when there are at least two elements, when there are two elements in the list. So if list has only one item, we cannot do anything. So what we need to do here, that condition should be verified. So in order to verify, we know that always R is greater than or equal to P as per our approach. R is greater than or equal to P. If R minus P, if R minus P is less than 1, see, we have two elements, 0 index, 1 index. So as per this, R is value 1 and P value is 1. Sorry, P value is 0. 1 minus 0, 1. Now can we perform this quicksort, means partitioning technique on this or not? Is it possible to perform partitioning technique? Can't we divide this into two partitions, two sublists when we have two elements?
We can divide, sir.
We can divide. So if only R minus P is less than 1, then we should continue for the next partition. Otherwise, we'll go with the continuous statement. I hope you know that what are all the statements presenting below this will be skipped and it moves with the next iteration. That's the whole idea. Now, okay, if r minus p is less than 1, that particular partition is having only one element. In that case, we cannot do partitioning further. Otherwise, what we do, we call Q equal to partitioning of A, P, R. A, P, R. So we are not updating this partitioning technique. It remains same. So we know that how it works. It is taking 3 parameters, and even here also we are sending 3 parameters. After sending 3 parameters, it assumes the first element as pivot and it places in the right position. After placing in its right position, that corresponding index will be written. That is our Q. Now after this, after getting Q value, what is our left sublist range and right sublist range? Can any one of you? P2
Q minus
Q
1.
minus 1 and right list is Q
plus 1
plus
to R.
1 to R. So we are only in the stack, we are sending only these indices. So which one is going to execute first, left sublist or right sublist?
Left.
Left. So we should first push this element followed by this one, then this one, then this one. Okay. So now again we are pushing S1 dot push insert P S1 dot push Q minus 1. Okay, then S1 dot push Q plus 1 and S1 dot push R. Two sublists. This is one sublist range, and that's why we are at a time we are popping two elements. Again, when P and Q minus 1 are pushed onto the stack, now again R and P, R gets Q minus 1 and P gets P value. Then again it compares whether that particular partition is having more than one element or not. Accordingly, if that particular partition is not having more than one element, it will continue, means this entire thing will be bypassed. Again it goes back and it checks that are there any left side elements or not. So if there are no left side elements, then again it pops, then it goes to the right sublist. Done. So it is end of the while loop and end of the quick sort. So it is just whatever we are calling recursively here, the same information we are maintaining in stack. By using that stack, we are made it to a iterative problem technique. Is this clear? Any doubts in this? Should I trace out this problem? Any doubts? Or should I trace out with some example? Does anyone require tracing of this problem with some example to understand it better, or not required? So in this example, we have discussed how to convert a recursive approach into iterative approach. Now, reverse engineering. Let's take some problem, very good problem on iterative problem, and let's convert into recursion. Let me take some problem of iterative technique 2. Okay. Write a program using recursion to display following pattern. See, again, this competitive coding thing is becoming an another standard class. See, one simple thing I will tell you. Uh, let's say I know how to swim well. So I'm every time I'm jumping into pool, once in a pool, next time in a lake, okay, then river, then sea. Every time I am just swimming, and to show you how to swim, unless and until you get into water and you drenched, you cannot learn how to swim. Similarly, programming is also. How many problems I would discuss, it will not help you out. You need to solve the problems on your own. Then what is the better solution? Once you students come to the campus in the labs, I will give only problems as I can physically present and help during the lab session. That time I will not teach anything. Okay. Um, and one more thing is that by next week I might start problems on linked list. I have uploaded programs into basic programs into our MS Teams. Please refer them. Okay, display the following pattern. One simple pattern, but it should be done using recursion. 1 2 1 2 3 1 2 3 4, like this up to n. We need to display. So the simple program is what we need to take: get n value from user. Okay, get n value from user. I am giving iterative technique. Now your task is to convert into recursive approach. So first we need to declare these variables I, j, n. After getting input from the user, I equal to 1, I less than or equal to n. For j equal to 1, j less than or equal to I, j plus plus, system.out.print, display j value. In every ith row, we have to display numbers from 1 to I. So j then system.out.print /n. We should move to the next line. So this is the main, in the main method, we can, by using these two loops, we can display this pattern. Now practice session is convert this into recursion. First, you try it on your own, then we can. Hello, does anyone completed? Hello. Hello, how to convert this into recursion, recursive approach? There are two simple techniques. Technique 1 is start from innermost loop to outer loop, like while considering recursion, from innermost loop to outer one, to outer loop. Technique 2 reverse, from outermost loop. See, here we have only 2 loops. In some cases, we might end up with 3 loops also. So from outermost loop to inner loop. Let's follow this technique 1. So first convert this into a recursive approach. So first we have main method. Then for I equal to 1, I less than or equal to n, we'll call m1 of I. m1 of I comma initial j value 1. I comma initial j value 1. This initialization is required, no, and I is required for inner loop to check that exit condition. Okay. Now after this I will display new line character. So now this M1 is a recursive method. It should be a recursive method. It is taking two parameters I and j. J value is we are passing here 1. Okay, every time for every ith iteration j should be initialized to 1. That's why we are always sending 1. Now what we do is if j is less than or equal to I, then we should display j value. Then recursively call I comma j plus 1. In the next iteration we should call. So we know that after some finite number of iterations, this will be going to terminate. Then it goes back to for loop. Again I will be incremented and it checks with the n value. If it is less, I is less than n, then again we are calling this recursive approach M1. So what we have done here is that complete iterative approach converted into partially iterative. Now this thing should be called recursively. So for that what we do, void M2 int n comma condition value and int I. If I is less than or equal to n, then first call M1 comma I value comma 1. In every ith iteration we should pass only 1. So we are calling this method. After recursively M1 completes, then it returns. We should recursively call M2 of n comma I plus 1. Now what happens is here, here we remove this entire thing, and in the main we call the initial method. Initial method is M2. M2 of n value. Anyway, we need to get n from user. Then initial I value is 1. So M2 receives n value 5, I as 1. Since 1 is less than or equal to 5, condition is true, then we are calling M1 of 1 comma 1. Since 1 is less than or equal to 1, it displays value 1. It displays value 1. Then after every iteration, we want to keep system.out.println/n. Done. That's how you need to convert like iterative into recursion. Clear? Any doubts in this? No? Any doubts? Okay. Next pattern is second problem. Is first write a program to display. Later we can think of recursion. Write a program to display following pattern. Okay, following pattern. Zero, 2, 3, 4, 5. 1, 0, 3, 4, 5. 1, 2, 0, 4, 5. 1, 2, 3, 0, 5. 1, 2, 3, 4, 5, 0. Like this you need to display. Try this problem.
Completed, sir.
Completed.
Yes, sir. Iterative.
Mm. Iterative. Now convert that into recursion.
Okay, sir. I will try.
done, sir. Can I convert into recursion?
Sorry.
I have done with using loops, sir.
Okay. Once you are done with loops, can you convert into recursion?
Okay,
See,
sir.
you will be tested. I think you are getting right output, no? Like when you run this, so no need to verify that. So, are you taking what can I say? N value? It is not fixed pattern.
Yes, sir. I
As
have
per
taken
n.
n from the user.
Okay, yeah. Then fine. Those who have got by using iterative approach, try to solve recursion. Then I'm just interested to know how you guys have done.
Done, sir.
Done. Okay, just a minute. Yeah, can you share your screen?
Yes, sir. Can you see, sir?
Yeah.
I would
So
define
first,
actually. Yes, sir.
yeah, first go to main. No, from main we can understand.
Taking input from the user and sending the
Okay. Then
yes,
whenever
yes.
I is equal to 0, you are displaying 0. Otherwise, j.
Ah, yes, sir. This yes.
Okay. Okay. Then m1 if j less than n equal to print 0 else. Go down.
Same logic, sir.
Yeah. Yeah.
Again,
Yeah.
outer
Hmm.
loop M2 logic.
Hmm. Yeah. Okay. Fine. Slightly modified. Yeah.
Yes, sir.
Hmm. Yes. Fine. Okay. See, others at least try, simple problems. Otherwise, showing 9 pointer and not able to complete programs is not to offend anyone. It's like completing degree from CSE and without proper programming skills is a physical disability. Whichever side you go, higher studies, research, industry programming is very much required. Without that, you cannot survive. Please start practicing. Okay, and this week we have another two sessions, 1 hour sessions. I will take problems on strings and arrays, but from next week onwards, plan is to start with the linked lists. So I have shared, I guess, 4 programs or 3 programs. I don't remember exactly. Single linked list, double linked list, and circular single linked list, I guess. Please refer them. I have made, see, those programs I have executed almost 3.5 years ago. I think when I taught for 18 batch, I don't know whether I taught for MTSC or for MTSC 18 batch. I taught one course. I'm not sure whether it's object oriented
Data
programming or
structure, sir.
DS
Data
or
structure.
DS.
Yes, sir.
Okay, okay. Yeah, maybe that time only I executed those programs. They are of 18 version. You can refer them. Like I have maintained comment lines. If you have any doubts, you can put message so that in MS Teams, then maybe I will address all the doubts once, a kind of revision. Then see, I need what I need from you guys is some basic work from you, homework from you. Then we can start with the advanced problems. From linked list, we can discuss plenty of problems. Okay. Okay, then thank you all. We can sign out now.